All right, so the next gas law we're going to talk about is called Charles's Law. And this one, the guy was a hot air balloonist, and he noticed that when you increase the temperature on a gas in a container, the volume of the gas increases, as long as you keep the pressure and the amount of gas constant. So as the temperature increases, I want you to think about those ping pong balls again. The gas particles start to move faster because that's what kinetic energy is. It's directly proportional to temperature. So the particles are moving faster and faster, hitting the walls of their container more frequently and with greater force. And if the pressure is going to remain constant, in other words, the pressure is not allowed to increase, what's going to happen is the volume of the container is going to increase. So what his gas law says is that the volume of a given amount of gas is directly proportional, so directly proportional to its absolute temperature in kelvins at constant pressure. What it looks like this is V1 over T1 equals V2 over T2, as long as temperature is in kelvins. Okay, I'm going to say that over and over and again. You got to remember that. So let's do a sample problem. If a helium balloon in a closed car occupies a volume of 2.32 liters at 40 degrees, the car is parked on a hot day and the temperature inside rises to 75 degrees, which would be really hot. What's the new volume of the balloon? So again, I recommend highly that you guys take the time and fill in for each particular variable. So here's my volume, 2.32 liters, 40 degrees Celsius. When I see that 40 degrees Celsius, my first instinct is add 273 to turn it into kelvins. Car is parked on a hot day, temperature inside rises to 75 degrees C. Again, add 273 right away. And you're looking for the new volume. Okay, now again, the units have to match. Now temperature has to be kelvins. So the volume units will match also, and you'll get liters. So if you set this up, and I know that algebraically this is a little bit more difficult, you got 2.32 over 313 equals x over 348. And so the way I would normally solve a problem like this is I would cross multiply. Okay, so I get 313 times x equals, and then I would do 2.32 times 348. I get 807, and then I would divide by 313. Now I'm writing these steps out, and if you struggle with algebra, this is definitely something that you want to write out. You don't want to try to do it all in your calculator, all in your head. And I got 2.58. Now I want you to think about that. They use units in liters, 2.58. Now it's not a obvious double, but it's definitely an increase in temperature, which means you would definitely expect the volume to increase, which it did. Okay, so there's a way to kind of check your answers and see if they kind of make sense. In particular, you should never get negative answers for volumes. Can't have a negative volume. Okay, so go ahead, take a minute, pause the movie, see if you can do this one. Okay, and the reason this one's in here is I just want to point out one thing. So V1, T1, V2, and T2. And again, here's my first situation, 0.67 liters, 89 degrees C, add 273 automatically, and I want to talk a little bit about what it's asking for. So you get 362 Kelvin. Okay, now I know the question's asking, well, at what Celsius temperature will the volume change to 1.12 liters? I know it's saying that. And we will deal with the fact that it says Celsius temperature, but anytime you're using a gas law, anytime you're using one of these proportionalities, it has to be in kelvins, because it's all based on multiplication and division when you're doing these gas laws. This is an addition, and it's not going to work if you don't put it in kelvins to begin with. So 0.67 over 362 equals 1.12 over x, and again I would cross multiply, and if you struggle with algebra I would absolutely write this out. Divide by 0.67 and you get x is 605. Now keep in mind that is in kelvins, okay? So if it did say at what temperature, you'd be fine. But since it says Celsius, what we're going to have to do is we're going to have to subtract 273 at the very end to figure out what it will be in Celsius. You cannot do Charles's law using it in Celsius. If you put 89 on the bottom here, you're going to get a completely different answer. Okay? It's only proportional, directly proportional when it's an absolute temperature. So even if the problem says Celsius, you just do as if it's got to be in kelvins and then fix it later.